लाइट्स ऑफ कर दो.
So, very good evening, good morning to all of you. And myself, Subhashish Bhomik from IST Shibpur, Howrah, West Bengal. And today, the talk will be on IoT, robotics, and automation. But I don't know that I don't know about the audience part of you. Okay, so whether you have a general knowledge or the idea about the robotic systems or not, so that I am not very sure. Also, I am not very sure that in which discipline it belongs to, whether it belongs to mechanical engineering, whether it belongs to the electronics engineering, electrical engineering, computer science, software engineering, so that I also don't know. But if you see this mechatronics, this robotics, automations and IoT is basically an interdisciplinary field. And all these fields are generating from one field that is known as mechatronics. Okay, probably all of you heard about this particular term of mechatronics. And then from mechatronics, this robotics concept, automation concept, IoT, and all others, means big names that we generally we heard about nowadays. So all these technology came from the source of mechatronics. So I thought that it will be better that if I can give you some basic information about this mechatronics and robotics, then only transferred into the advanced topics of IoT. And along with that, I will try to provide you some glimpses of the work that is going on in our laboratories in IST Shibpur. And these are all related to the robotics field. The basic objective of providing this idea to you is that maybe some of you may be interested in some other fields of robotics. May not be that all of you will become a specialized person in the field of IoT. Okay. So along with the IoT, definitely IoT will be there, but along with that, there are some other topics will be discussed to you. I will try to give you a flavor of some other ideas, some other topics also, so that also you can think of your further research, or if you are doing masters, then what kind of project you will do it in your institute, that you can also think. If you are a PhD candidate newly joined, so you can think of that whether we can work in some other areas of robotics, automations, or in the field of IoT. So you can see that this first slides, it indicates the field of mechatronics. Okay, and in the field of mechatronics, if you see on the left hand side, there are 4 circles are there. So one is known as mechanics, which is basically relevant to mechanical engineering field. The other is electronics. The third one is control systems, which is basically the part of electrical engineering field. And the fourth one is the software engineering, which is the field of computer science. Now, when this mechanics and the electronics combine together, we have a subject which is known as electromechanics. When the electronics and the control systems combine together, we have a small zone which is known as control circuits. When the control systems and the software engineering combine together, we have digital control. And when the software engineering and the mechanics combine together, we have a subject which is known as computer-aided design and computer-aided manufacturing. Now, when these 4 electromechanics, control circuits, control systems, digital controls, and your CAD/CAM combine together, then there is a small zone is there, overlapping zone is there, which is known as mechatronics. Okay. So if I see the core part of mechatronics, it is basically an interdisciplinary subjects where the electronics, mechanics, mechanical engineering, electrical engineering, and the software engineering combined together. And so we can say that if you want to be an expert in the field of mechatronics, probably you will require a basic knowledge or basic understanding of these four different branch of engineering. Now, if I go inside the mechatronics, then you will find the robotics. So, within this small area of mechatronics, there is a field which is known as robotics. If you want to be a mechatronics engineer or a robotics engineer or an automation engineer, probably we say that you will have these 4 quality of I's, 6 qualities of I. Now, what is these qualities? I stands for imagine, I stands for initiate, I stands for innovate, I stands for invent, I stands for inspire, and I stands for integrate. So, as a person to be a successful robotics people or successful mechatronics engineers or an automation engineer, you should have all these 6 I qualities. Okay. Now, if you see the terms, mechatronics terms, it was coined in 1969 by a Japanese company which is known as Ishikawa, and they have used this particular word, which is basically a combination of 2 words. Mecha is coming from the word of mechanical engineering, and the tronics is coming from the electronics field. So, we basically we say that it is basically a merging of, in a broad sense, it is a merging of mechanical engineering and electronics engineering. This is a factory, okay, and this is an automation factory. This is an advanced factory. The advanced factory, it looks like this type of, this is the look of an advanced factory. So, at the bottom floor, if you see that the bottom floor, there are so many advanced machines are there. We call, this is generally we call as a CNC machines, and there is a robot here. So, you can see there is a robot. There is a conveyor belt system is there, material handling devices are there, and on the top floor you can see that the people are sitting on the top floor and they are working with the computers. So, basically the task is to write the code, write the program part, so that whatever the action is required at the bottom floor, at the shop floor, that can be taken place. So, the definition, if you see the fundamental definitions of mechatronics, you can read it. Like a mechatronics means the synergistic combinations or integrations of precision mechanical and electronics engineering in the morphology of the design of either the product or process. So, the robotics of the mechatronics is either it is connected with the product development or it is related to the process development. So, the prima facie for the integrated approach of design of complex engineering systems lead to the doping of the concept of electronics and control systems in it. So, basically what happens nowadays, you I think it will be better that if I show you some examples of this kind of products. These are products. Okay. So, all of you have seen a photocopying machines, all of you have seen a video camera systems, you have seen a electronic fuel injection system which is nowadays used in the advanced automobiles. There are micro pumps which are used for the pumping of the fluids, okay, or we can say that the pumping of the medicine into the patient bodies. So, there are certain, there is a certain requirement is there, like sometimes the doctor wants that the medicine has to be injected into the patient body for a duration of 24 hours time period. So, 10 ml of fluid has to be injected into the patient body for a duration of 24 hours time period. So, whenever the normal injection process is taken place, okay, so 10 ml fluid is entered into the patient body within a fraction of a second's time period. So, there must be some sort of mechatronic systems should be there, some sort of automation system should be there, automatic systems will be there, which will work for 24 hours and it will inject the plunger in such a way that there is a very small micro level of displacements will be there. So, continuously fluid will be entered, medicine will be entered into the patient body, but the durations of the time period will be of 24 hours time. Then anti-lock braking systems, okay. So, most of the cases nowadays the four-wheeler systems, they comes with the anti-lock braking systems. The mechanisms or the control systems which is used for driving all these particular products, they are nothing but a mechatronics. So, with this little bit of examples of mechatronics, let us move to the field of robotics field, give you a little bit of flavor of the robotics subjects. Okay. So, if you see the formal definitions of the robot, Okay. So, an automatic apparatus or a device that performs functions ordinarily ascribed to the humans or operates with what appears to be almost human intelligence like. Okay. And this is basically the Webster definitions of the robots, but the actual working definitions of the robot that has been given by the Robotics Institute of America, and this is from the applications point of view. So, these application, this definition is a robot is a reprogrammable multifunctional device which is designed to move material, parts or tools from one location to the another locations in a repetitive way in a programmed form. So, that is the basically the means you can say that these definitions is more appropriate from the common perspectives. Okay. Now, these robots this is the general look of a robotic system robots. So, those who have not seen a robots, okay, so they can imagine that what how it looks like. Generally, this is known as a manipulatory unit. We call it as an electromechanical system. It is like a just it is like a machines like, okay. And this is the controller part which controls the operations of the robots, control the operations of the machines. There is a teach pendant through which you can operate the robots. You can move the robot from one location to the another locations. You can do it, and there is also a computer interface is there. So, through this computer interface, you can write the code of the program and then execute the programs. You will find that the robot is working. Okay. So, we generally say that these are the four fundamental components of any kind of robot. So, these two, this teach pendant is basically for the communication purpose. How the robot will be communicated, how the human will communicate intentions, the working intentions of the person to a robotic system. So, that can be performed either by the or by a computer. So, whenever I want to move the robot from one location to the another location, that I can do it with the manual, generally called as a manual control system. Or if you want that automatically the robot will move from one location to the another location, then you can do it with the help of a computer. 3D applications of the robots, where the robots will be used. So, number one is the dirty, when the environment is dirty. So, you can think of because if the situation is dirty, the environment is dirty, then it may not be possible for a human being to do this kind of activity for the robot. So, for that purposes, the environment is dirty. Only you can think of replacing a human being from that dirty environment by a robot. The second one is the dull. Dull means the kind of repetitive type of things. Say for example, if a person is supposed to do, if I am supposed to do a task repetitive way, like I have to pick up the bottle and then bring it to and put it over here, then I have to again have to repeat that place. I have to again pick up the bottle and place it over here. So this is a kind of repetitive type of task, monotonous type of task. So you can remove the human being from this type of task and you can replace this human being by a robot. Number two is the situation is dull, the environment is dull, the action that needs to be performed is dull. The third one is the dangerous. Like say for example, in case of a radioactive power plant, okay. There are certain tasks are there which needs to be performed by a human, okay. But the environment is basically that environment is a hazardous environment, radioactive environment. So you cannot send a person to that kind of to do certain type of task, okay. Human cannot be moved, cannot be located at that locations. So you do not have any other options, but you have to apply a robotic systems, because the robot, as it is not a living elements, okay. So whether the environment is hazardous environment or whether the environment is a dangerous type of environment, it does not have any effect on the robotic systems. So this 3D is very important. Think about the dirty, when the environment is dirty, okay, and the nature of work is dull type of nature of work, or when the environment is or the actions that needs to be performed is a dangerous type, then only you can think of applied of a robotic systems over there. Let me check it. Okay. So you see that this is a robot, okay, and this has been installed in our laboratory in Jamshedpur, and this robot is known as a KUKA robot, okay, and it is basically it is a German make robot, and this robot it can move from, you can see that it is moving, okay, and it has been pre-programmed, so it is following the instruction that has been written by some student in a computer screen, and when the program is executing, the robot is moving from one location to the another locations. Now this is an industrial model, this is not like a laboratory model, this is a full-fledged industrial model, and this robot can handle a load of 5 kg load. So if you put a load of 5 kg load to the robot's gripper, okay, robot hand, then it will be able to move it with that particular load. Now you can see that this is another robot, okay, and we generally call these as a Cartesian type of robots. Now this is not an actual robot, these are simulations, okay. So sometimes what happens in most of the cases, the academic institute, we are the poor institute, financially we are very poor institute, like academic sections, okay. So we may not have the fund to purchase the robots, and that robot nowadays it may be costing about 25 lakhs. So maybe that for all the institute they cannot invest these 25 lakhs of rupees for the purchase of a real robots. So what we generally do, we try to give the try to show how the robotic system works through the simulation. So I am just showing you one simulation model, and this is known as a Cartesian type of robot. So you can see that the robot is moving along the x axis, the robot is moving along the y axis, the robot is moving along the z axis. So we have a 3 axis, this has a 3 axis motions. So it has an x axis, y axis and z axis. Also it can have the 3 axis at the gripper end. Okay, generally we will say that the robots of 6 degrees of freedoms. Most of the robots are 6 degrees of freedom. So 3 for the position purposes and the 3 for the rotations purposes. We generally call the pitch, roll and the yaw, and these rotations they are provided in the gripper end. Okay. This is another robot, okay. This robot is, you can see that it looks like a human hand is moving like, okay. The motion, if you compare it with the first one that I have shown you, okay, so that is known as the KUKA robot. So if you compare the operations of the KUKA robot with this robot, this is known as a Kinova robot, okay. And this robot's movement is very, very smooth, as if human hands is moving like, okay. Say for example, if the robot is asked to draw some picture like, okay, you require very smooth motions, hand movement should be very smooth, and that can be achieved with this kind of robots. So you can see that the robot is pulling a drawer, okay, and pick up some objects from the drawer, and then it is pushing the drawer inside it. The operation is so smooth. And this kind of robots is called as a dexterous type of robots. Dexterous, okay, like a human body, human hand, okay, a human body. This configuration, our configuration is very, very dexterous in nature. Okay, I can bend my body in any directions, any way I can bend. I can bend my hand also in any directions, any motions I can have, like very smooth movement I can have. So this similar kind of motions is achieved through this type of dexterous robotic system. So this is another category of robots which looks like a human type. More on looks like a human means it is not like a human type. its operation, from the operational point of view, it looks like a human. This is another robot. It's a very simple one. Okay, it's a kind of desktop type of systems, desktop type of robots. You can place it on a table. Okay, and generally most of the cases what we do, we take this type of robots to the classroom and for the teaching purposes, so that the students can understand, they can see the inside of the robots. Generally, if you see the industrial model of the robot, everything is covered, like you don't know that what is happening inside it. Okay, it's like a, looks like a black box type. But this type of robot systems, this is this type of robotic systems is very open type of structures. Open type. What is inside it? You can see the mechanical parts. There are gears, there are bearings, okay, there are chain, there are belt drives, there are bush, okay, and then there are shafts, there are mechanical structures, everything you see it. And also you can see the positions of the motors also, actuator units, where the actuators are placed, like whether all the actuators are placed at the base or the actuators are placed at the different joints, that you can also see from here also. Okay. So these are for the pick and place type of operations. Mostly the robotic systems are used, most of the cases the robots are used for pick and place type of operations. Okay. And in the industry also we require this kind of robots also, not in this small form but in a bigger form. But the main purpose of the applications of the robot is for handling of the material from one place to another place. That is possible. Those who are from the non-mechanical background, only for them, okay. So because all these terms will come when we will go into the IoT systems, okay. So that's why I'm just giving you the fundamentals, okay, preparing you for, so that you can absorb the concept of the IoT. Now these are machines, okay. All of you have in the first years at the undergraduate level, you went to the workshops, okay. So you must have exposed to the workshops, at least in the first year level. So there you have done some sort of machining operations. Maybe you have seen a lathe machines, maybe you have seen a drilling machines, shaper machines, planer machines, okay, and you have made some sort of components, work pieces also. So you were given some sort of raw materials from there, you have to machine it, and you have to create a finished products. So that you have done it through the conventional machines, conventional lathe, conventional milling machines, which are basically manually operated or manually controlled. But now the manual control machines has been upgraded, and we have the CNC machines right now. The operations, fundamentally the operations remain the same, only the control has been changed. Previously it is a manual control, now it is an automatic control. Automatic control means it is the programs, okay. Generally we called as a G code program or M code programs, or sometimes it is also called as a APT programs, advanced program tooling programs, okay. So this is basically a code, you have to write the code, and you can write the code over here, and you save the code, execute the code, you will find that the lathe machine starts its operations, okay. Like this is the finished product that has been prepared. This is the finished product, and this has been achieved with the help of the lathe machines, and this is computer controlled machines, okay. So when the IoT will come into the picture for the manufacturing sector, all these robots, these CNC machines, they will be coupled together. Unless and until they are coupled, so we will not get the real benefits of the IoT systems. So It's not taking. It's not coming. I put it in the slideshow. Oh, okay. So, the actual title of the talk is IoT, transforming the world where the AI and the ML meets robotics. Okay. IoT you know, okay, and by this time also you came across the terms of robotics. Now this IoT is basically the Internet of robotic things, Internet of things, and from there you move further inside. This is Internet of robotics things. As the name suggests, in the Internet of robotics things, definitely then the robot is also involved. Robot is involved. So if robot is not involved, we should not call it as IoT. Transforming the world where the AI and the ML meets robotics. All these terms like AI terms, ML terms, already all of you have heard about these terms. Machine learning, artificial intelligence, this is part of our normal curriculums. Even a mechanical engineer, even a civil engineers, they have to study the subjects of AI and the ML. So when the robotics comes into the picture, definitely a robotics man should have a knowledge of AI and the ML. So the title here, that industry means Internet of robotics things, is a one aspects, and this Internet of robotic things is now it is upgraded further with the help of the AI and the ML. So in normal case, what happens, Internet of robotics things or Internet of things, whatever you call, you just get some sort of data, some sort of information through the different types of sensors placed in the surroundings, okay, or to the devices. Then from that data, from whatever the data you are receiving, that raw data, generally the people use it for communication purposes, or what I say that for the instruction purposes to the machines. Say whether a machine will start its operation or not, so that depends upon the data which is coming from the IoT. Now in sometimes what happens, whatever the data is coming from the machines or captured from the machines, this data may be a corrupted data, okay, or sometimes it is very dangerous that if you supply these raw informations to the machines, so you need some sort of processing, and this processing will do the processing such a way that ultimately from the data it will extract, you will extract some informations, and these informations, extraction of these informations, it will be through the AI and the ML techniques, applications of the AI and the ML techniques, okay. Converging, sensing, actuating, hyperconnectivity, artificial intelligence at the IoT platforms. The new IoT AI innovation equations, this is a new term like, okay. So I have given a small titles, okay, same thing but in a different form like. So one is the IoT AI innovation equations. Now equations we all know, okay, and this IoT AI innovations equations means is a couple bonding between the IoT and the AI, and it is creating a new equations, and these equations are not a very general type of equations, okay, it's a kind of innovations equations. That means these equations, when the IoT and the AI will be clubbed together, probably they will be able to generate some product, process, systems, whatever may be, that is innovative in nature. All the time whenever we do some sort of project works, everybody asks that what is innovation in your work. If you develop any product, people will ask you that what is innovation in it. Innovation means something different from the rest, something different from the rest, or whatever is available in the market, okay, your product is something different. So when we combine this IoT and the AI concept, then it may generate some new equations, new idea, and which will ultimately, it will create innovations in your product, or in simple way, it will create innovation in your dream. The next great leap forwards, question mark is there, combining robots with the Internet of Things. Now when the everything means most of the cases we see that there are certain fields are there which more or less it is a saturated fields. Like if you see the conventional, as I am from the mechanical background, so most of the cases my examples relates to the mechanical engineering. Now as such the mechanical engineering, hardcore mechanical engineering, okay, there is no innovations right now. We can say is a obsolete technology, like mechanical engineering is becoming like an obsolete type. There is no innovation, there is no new thing coming up in the mechanical field. Okay. So how to improve the content of mechanical engineering? That you can do it with the help of this when you add something new with the mechanical engineering. And that's why we call that when the mechanical engineering is combined with the electronics, a new branch of engineering opened up. Mechatronics engineering it opened up. Okay. So only mechanical, most of the cases the people may not find interest in the mechanical engineering. Okay. So when you combine the electronics, then this gives a different flavor to the subject matters, completely different flavors. So combining robots with the Internet of Things, probably it is the next revolutions in front of us. Like we will come into the different types of industrial revolutions. Okay. Already in this industrial revolution, this robotics and the IoT, it plays a very important role in the industry 4.0. Yesterday we also mentioned like that. So in these situations we can say that whenever this concept of robotics and the IoT combines together, probably we will have a bigger and greater advantage in the futures. Understanding machines, explainable AI. Okay. Sometimes we do, sometimes say for example we do some work, but we don't know that why we are working. There is no reason behind our work. So sometimes the machines also do some activity, okay, for which we do not find any reason why the machine has done this kind of activity, this kind of work. Like sometimes, say for example, the machine is working, suddenly it stops. Suddenly it stops. You do not have any clues that why the machine stopped its operations. So this concept, this understanding the machine's explainable AI, we are applying some sort of AI concept that why the machine is stopped its operations. Okay. And we are finding some sort of explanations from the AI related activities of the machines that why the machine stopped or suddenly machine starts or suddenly the machine is malfunctioning. So all this we are trying to find out with the help of this IoT and the robotics, AI and the ML concept. So when all these four branch of knowledge will combine together, then definitely we will have a better life for the industry. So the fourth industrial revolutions is the prevailing movements where the disruptive technologies, trends such as the Internet of Things, robotics, artificial intelligence, autonomous vehicles. Probably all of you have heard about this kind of autonomous vehicles. Now the vehicles are coming out without any driver and it can move from one location to the another locations, okay, without any accident. Like how it is possible? Blockchain technology, cloud computing, social media, communications in the social media. So these are the new terms which are coming up, okay, and these are all becoming part of industry 4.0. Here you can see that this is Internet of Robotics things at the middle, and you can see that there are some other branch of engineerings they are connected with it. And what I like to show you that whatever be your field of engineering, whatever be your discipline of engineering study, you can contribute for the field of IoT, in the field of IoT. So as a mechanical engineers, as an electrical engineers, as a software engineers, as a computer science engineers, as a mathematicians, as a material science engineers, as a person from the law or person dealing with the AI, cognitive science, maybe the doctors also, okay, psychology, physics, biology, all are connected like. So if you think of a this particular area, industry, this Internet of Robotics things, this is such a broad area where each and every branch of engineering can contribute. And if you look into this particular area, you can see that if you say, for example, if you are an electrical engineer, where you can contribute. It shows, this picture shows. If you are a software engineer, how you can contribute in the field of IoT. That has been shown. So we call these as an interdisciplinary branch. Okay. So far it not has come out as a single branch of engineering like computers or electrical or mechanicals. Okay. But maybe you don't know that what will happen to the future, for the future IoT. Maybe a new branch of engineering will come after maybe after 10 years, after 15 years, we will have a choice like whether we will whether the student will go for the mechanical or civil or electrical or chemical. Also at the same time the students can go for the IoT also, that particular field also. So Internet of Mobile Things, Autonomous Internet of Things, Autonomous Systems Things, Internet of Autonomous Things, Internet of Things Cloud, and Internet of Robotics Things. Okay. So they are basically we can say that the different names of IoT field. Okay. So sometimes whenever it is of mobiles, communications, okay, we call it as Internet of Things mobile. Okay. And when the robots are involved, we call it as Internet of Robotics Things like. So these are the different names, okay, almost is a synonymous in context like, okay, and which will give you an idea that how this IoT field, this is basically it is expanding. Now already I think yesterday you have some sort of practical experimentations, okay, you have done certain some practice, okay, you have seen some IoT based systems developed in this institute. Okay. Now you can think of some other field, some other application. Like say for example the garbage monitoring, whether a dustbin has been full with the waste material or not, how to get it. How you will come to know that when the garbage that bin needs to be changed or cleaned. So this is one of the areas. So and then industry automation using Raspberry Pi. I have just given some problem statements like these are definitely these are the problem statements. Then asset tracking systems, okay, home automations, biometric attendance, office automations, weather reporting, liquid level monitoring, smart energy grid, theft detections, ICU patient monitoring. These are all means applications areas of IoT. So you can think of taking a project at the undergraduate level, mean the BTech level, or you can, if you are at an MTech level, so you can think of a project from all these means examples areas. Or even if you are a PhD student, you can think of whether it is possible to formulate a problems, real problems, out of this 10 or 12 applications areas. So the opportunities that come with the IoT, these are enormous and can be the game changing for the business embarking on a automation transformations. These are all real problems. These are all real problems, related problems. Okay. This is not like a fictitious problems. Okay. And if you work, you can try to give a solutions in these particular areas. These particular slides, it provides a philosophical thought that whether this IoT should be called as a evolution or it should be called as a revolutions. Okay. So you can see that there are two examples are there. One is that of a car. This is an early carriage. Okay. And then through its evolutions, okay, so it becomes a fancy car, and then further it has been evolved further, and then a revolution came when this type of fancy car, it was transformed into the early automobiles. That means that early automobiles means how the early automobiles looks like. Whatever the automobiles we have right now, okay, if you see the early automobiles 60 years, 60, 70 years back. Now from this early carriage systems which was basically driven by the human, okay, or it may be driven by the animals. Now how this early carriage has been transformed into the present automobile systems, and that is basically the revolutions. Now you can see the next examples is the telephone, okay. So from this shape to this shape, it is basically the evolution. Evolution means a delta amount changes is taking place, and from this early digital phone conversions into the mobile, it's basically it is a revolutions. Is the revolutions, okay. So it is not a delta amount of changes is taking place, a huge amount of change, conceptually completely different things has been developed from the earlier versions, and this should be called as a revolutions. So there is a question mark is there that whether we call this IoT, it is basically a evolution process, evolutions, or it is a basically it is a revolutions. Now this shows the manufacturing industries, industry 1.0 to industry 4.0, okay, how it looks like. And if you see that industry 1.0, I think I have a better visualization. Okay. So you can see that initially industry 1.0 is basically the mechanizations, okay. The system was mechanized. Earlier it was driven by the human, okay, or it was driven by the animals or from some other source of power, and now these has been that kind of machines, this has been mechanized, okay. So in the case of a mechanical, that means from the mechanical perspective we can say that different types of mechanisms has been developed and integrated into the systems. So it becomes as a mechanized devices. The second industrial revolution, it was basically the we can say that the introductions of the mass manufacturing production systems. Yesterday I told that Henry Ford, those who have developed or those who have introduced automations, okay, factory automations or line automations for the assembly purposes, okay. So that was the industry 2.0. So this is basically the introductions of automations for the mass manufacturing. The third one is known as digital manufacturing, okay. So the third one is introductions of the electronic systems into the manufacturing. Previously the manufacturing was, it was like a 90% is mechanical and 10% is electrical, and now industry 3.0 there is a change, like, okay. So there is an introductions of electronics, there is an introductions of PLC systems, there is an introductions of robots, there is an introductions of IT concept also into the manufacturing sectors. So this is known as an industry 3. And the industry 4, you can say that the industry 4 is basically the introductions of IoT and the cyber physical systems. So we have a physical systems, physical machines it is there, okay. And the cyber physical systems means that the mechanical systems or electrical system, whatever the systems may be, it is connected through the cyber system. That means it is computer controlled as well as it is connected with the internet also. So this is known as a cyber physical systems. And here not only the IoT is there, but along with the IoT there is another subject matter is there, which is known as an AR and the VR, augmented reality and the virtual reality, okay. So these are all this new field of engineering, new field of concept, okay. So they are merging into the industry 3.0 and ultimately it is transformed into the industry 4.0. So you can see that from these pictures, okay, disruptions on age of accelerations, then profound and systems change, momentous changes. So these are the part of industrial revolutions. For any kind of industrial revolution takes place whenever the change is not delta. Okay, it is not the change in the micro form, it is the change in the macro form. And macro form changes means something different, something new, something different has been introduced into the systems, and which is creating disruptions. Okay, disruptions means it is like it is breaking the conventional rules, conventional norms in the factory, and that kind of technology, we are looking for that kind of technology. And from the IoT is one kind of technology which is practically speaking which has brought disruptions into the industry. So if you apply this concept of IoT, you will have a gain, you will have an advantage. If you are not applying the concept of IoT, probably you have to die. Industry has to die. Okay. So technology is driving the change. We require change. Always we expect. Okay. Change is basically, it is a dynamic process. And sometimes we say that if a person becomes static, that means the person is already died. Okay, so a person also needs to be a dynamic, and changes is a symbol of dynamics. There are so many companies are working in this IoT field. Okay, so basically this is the landscape of IoT. Which are the companies working in this particular field, and all the big companies, they are either working at the ground level, okay, or they are applying this concept of IoT into their field. Yesterday also we talked about the smart city. Okay, so IoT can be considered also for development of the smart city. The role of AI in the field of IoT. So have you ever wondered how the everything around us is becoming so smart? Each and every time we are finding that machines or the systems are becoming smart. They are becoming smarter and smarter. Now how it is possible? How the gadgets possesses to make human-like decisions. A machine is there, but the behavior of the machine is similar to the behavior of the human beings. How it is possible? And how we are able to change our surroundings in just the click of a button. So all of you know that before you entered into the room, before somebody entered into the car, okay, so your AC may be switched on. How it is possible? And all these are bringing sea change, either in the life of the persons, our personal life, or it may be the changing, maybe it is bringing a sea change in the industrial perspective. So Internet of Robotic Things, this is a field of research that describes the collaborations of the fields of Internet of Things and the robotics. So IoRT is also supported by the fields of edge computing, cloud computing, okay, cloud robotics, and AI in the IoT field. So IoT is everywhere, as I mentioned, okay, and you will find also the applications of the IoT in our daily life also, okay. So the household applications, in education, in the transportation, security, defense, then industrial work, healthcare, which not. You can include many more fields, application fields also. This is just, it is an examples, 5 or 6 examples has been provided over here. So the Internet of Things, it gives us a digital heartbeat to the physical objects. I was mentioning that in case of a physical object, it does not have a life. Like we think about that, you think that any machines, okay, it does not have the life. And the people are now trying that whether it is possible to give a life to the non-living things. And now we are getting some sort of means hope that maybe this IoT concept, if it is applied to any machines, so that will give some kind of life to the non-living things also. So the Internet of Things, it gives us a digital heartbeat to the physical objects. Internet of Robotics Things is a concept where the IoT data helps machines interact with each others and take the required actions. Now, in most of the cases, sometimes what we say, what we do, generally we gather the informations, collect informations. And collections of the informations will be of basically of no use unless and until you take any decision based upon the collected data. So you have to take some sort of action. And from that perspective, we can say this IoT, whatever the data or the informations we are capturing from the different source of the machines. So we have to make some sort of conclusions from the data received, and that conclusions must be transformed into some actions. Now say for example, you can see that this is a artificial hand. Okay, this is an artificial hands. Now there maybe some object is placed over here, some object is placed, or maybe there is a switch over here. So and this switch means depending upon the some situation, this switch needs to be operated. So if you gathered all the informations about the environment and ultimately if you are not taking any action, then there is no use of taking that all this data from the systems. So this robot is placed, means robot is connected with the in the IoT systems, okay, and it can push some sort of button. There is a button at the bottom, okay. So it is pushing some sort of button, some action is taken. There are two concepts are there, okay, in case of an IoT concept. This is one is known as a centralized cloud systems, okay, one is the centralized, another is the distributed edge IoT systems, IoT platforms. So as the name suggests, you can see this is a centralized one. So all the machines, they are connected to a centralized systems, okay, and here this is decentralized. All the machines can communicate with the other machines, other systems. They are communicating with each others, and also they are communicating with the central systems also. Okay, so this is basically this is a kind of hybrid type of system. So either you can have a centralized systems or you can have a distributed type of systems. And probably if it is a centralized system, it has a certain advantages. Okay, but the disadvantage of systems is that if the centralized systems, if the cloud becomes means non-functional, or if there is any problems happens with the central systems, then everything is stopped, like everything is stopped. And here in this case machines, you can see that there are so many systems components are there. Even there is a vehicle over here, there is a robot, okay, and there is a kind of camera systems in a this is known as a your quadcopter, okay, drones. So and then you have a smart watch, okay. So all are connected with each and every one, like, okay, distributed. One of the applications of these IoT systems is basically the generally we find in industry, okay. This IoT is almost means people are using this IoT, applying this IoT concept, and there are 4 or 5 specific areas that there in the industry where this IoT concept is used. One is the maintenance purposes, machine maintenance purposes, okay, and condition monitoring. So the whether the machine is has a tendency to malfunctions in the future, how you will understand it, okay. So for that purposes, you have to apply a robotics, you have to apply the IoT systems. So these machines must be connected with the IoT, IoT, and then only you can collect some sort of signatures from the machines. Like signature from the machines may be safely, say for example, a machine is working, at that time the machine is creating vibrations. There is a tremendous amount of noise is generated, or maybe the shop floor is vibrating. So this indicates that the machines may behave malfunctions in the future. Generally, if the machine is a balanced one, it will not create so much of noise, it will also not create so much of vibrations, ground vibration it will not create. But if the machine is creating vibrations, it is creating noise, okay. So that means it is an alarm to the operator that the machines may malfunctions in the near future. So what you can do, you can put some sort of sensors in the machines, maybe on the machine's bed you can put some sort of vibration sensors, accelerometer you can put it at the bottom of the machines, and from the accelerometer reading you can get the information that whether the machine's bed is vibrating or not, it is oscillating or not, that you can. Or you can put some sort of microphones in the machine side, okay, it will capture the sound waves and you process the sound wave, process it, okay, and then from there if you see the signature of the machine's sound wave that has been generated from the machines, so that will contain some information that the machine may malfunctions within a few days or within a few hours of time period. Then based upon the data you take immediately, either you stop the machine's operations, or you keep your maintenance people ready that whenever the machine will stop its operation, immediately that people will come and they will rectify the problem. Or you can do some sort of preventive maintenance also. There are different types of maintenance policies are there. Predictive maintenance, preventive maintenance, like that. Okay. So based upon this data that you are receiving through the IoT, based upon that you can take the decisions. Then manufacturing sectors, okay, it can be also used in the manufacturing sector. Then automated e-commerce, that is like we all know that the Amazon, okay, in the warehouse they are using robots, okay, and these robots are basically for pickup of the components, pickup of the objects, okay, from a particular rack, particular positions, and then bring it to the packaging sections, okay. So the people will package it, or maybe for the packaging purposes you may have a robot, so the robot will do the packaging operations. For that purposes it can be used. And there are so many robots are there. I don't know exactly, but may not be less than like 1,000 robots are employed. And all the robots are moving in the shop floor, like, okay. Like say for example that 1,000 people, they are walking from one location to the another locations inside this room. And if we are all intelligent, then we can avoid the collisions, because with this particular small space it will be difficult for us 1,000 people to move, like, okay. But if we are all intelligent, then we can avoid the obstacles, collisions, okay. So similarly these machines are so intelligent, okay, and so that they can also avoid the obstacles, or they can avoid directly they can also avoid the collisions. This is another applications of IoT, okay, and these applications is basically the medical field, patient care purposes. It can be used for the patient care, patient monitoring, continuous monitoring, 24 hours monitoring of the patient, and for the surgery also. And all of you have heard about that robotic systems are there, okay, and big hospitals they are applying a robotic system for the surgery purposes. So where the doctor is sitting in one locations and the patient is located in some other locations, okay. So basically the doctors, with the help of some new technology, advanced technology, okay, so they can operate on the patients. So the patients may be in Jamshedpur and the doctor may be sitting in Kolkata, but still the operations can be performed on the patients. With the help of these robotic systems, advanced robotic systems, with the help of these IoT systems, it is possible. Agriculture is one of the another important field where this IoT, one has to apply this IoT concept also. Okay, and because the conditions of the what I say, the mud, okay, conditions, the weather conditions. So based upon all these, you can take a decisions that whether a seed has to be implanted in a field or not. Okay, so that kind of decisions may be taken by a robot using these IoT concepts. So there is no need that the farmer needs to be present in the shop, or needs to be present in the ground level, okay, to the field. They need not to go there. So you can have a machines, not only the robots, but there may be, you may have some sort of autonomous type of systems, and they will collect the data or the informations about the weather conditions, about the mud conditions, okay, and then they can take the decisions, own decisions, like smart home, telepresence robots, okay, disaster management purposes is very highly it is used. Autonomous vehicles, already I mentioned that now there are driverless cars are there, so how they should be operated. There are so many, say for example, manually driven cars will be there, the driverless car will be there. They are all working together, like they are moving together, like. Sound system is there, voice. Whether the voice will work? Huh?
Sir,
It's mute.
I will start from the beginning.
Tension बैठा क्या मुझको? टेंशन उठू बैठा है।
This is in a very nutshell. It's not coming. It's unable to track it. You can put your, it's through mobile now? I don't know. You can put it there. I think it will be better, no? This one I don't know.
Today, data is everywhere. For companies, it's become one of the most important resources essential in the age of the Internet of Things. To unleash its full potential, we must transform this flood of data into
I'm trying to show that what is the status, means industrial status, means how this IoT robotics concept, this has been applied to the industry. Okay. And Siemens is now is a company which are those who are working in this particular area for a long time. Okay. And these videos is indicates that what is the level, advanced levels of IoT and robotics, how the industry is thinking, and they are applying this concept of IoT.
systems of various manufacturers to gather data from a multitude of sources. Advanced analytics and applications from Siemens, our partners, and other providers transform this data into valuable knowledge.
Okay, I think these videos are not coming in a, properly. I will show. Okay. So the last one was the applications of the IoT. And this has been developed by our students for the medical purposes, for diagnosis of some disease purposes. Okay, it's a bit small examples, small applications areas. Okay, so the patients means they are collecting the data or the informations from the patients. Maybe that they are collecting the heartbeat informations. Okay, or maybe they are collecting some informations of ECG informations they are collecting, and then this information is placed in the cloud, and then the data is processed. Okay, and then the processed data is provided to the doctor, so the doctors can see the patient's data, medical data, they can see it, and doctors also can analyze the data. Okay, and whatever be the prescription, so that prescriptions also they can put it in the web also. Okay, or sometimes the doctors also give some sort of means, say for example, as medicine has to be started or some equipment needs to be started. So immediately based upon the report, medical report, the doctors from there itself through the IoT, okay, so the doctor can start the operations of some devices like. So that is possible. I'm just what I can show you. Um, Okay. Now you see that uh, this is a uh, this is a robot. Okay. So previously I have shown you some configuration of the robot, and that configuration was looks like a very hard configurations. Like, say for example, see human hand. Sometimes we compare it with the robotic hands also, but our hand has a dexterous. But if you see the inside, the constructions from here to here, we cannot change it. It is like basically a straight line one. From here to here, this is basically it is a straight line one. Now there are certain tasks are there, okay, and this task needs to be performed by a robotic systems. So there say there is a debris, okay, there is an earthquake, and the building has collapsed. So there are debris. There are chances are there that maybe a human being has been trapped inside the debris. Now you have to find out, means you have to deploy a robotics type of systems. Okay. So you don't know that in your site, okay, there may be so many robots are there. Maybe 10 robots are there which has been employed for cleaning of the debris. But which robot has to do certain task? A particular task, which robot has to do a particular task? So that means informations or the actions or the duty to the robot, you can provide individually, you can provide it to a robotic systems. Out of these 10 robots, maybe you are asking a particular robot to move to a particular locations and search it, find out that whether any person has been trapped over there or not. Now if you think that you will apply a conventional type of robots for detections that whether any person has been still it is alive there in the under the debris or not, then probably you will not be able to do it. Okay, because the conventional type of robotic system, it cannot enter into the debris areas. So there it is useful that if you have this kind of robots, okay, and these are known as a continuum robots. Is a very special category of robots. It looks like, if you see, it looks like an elephant trunk. Okay. So the elephant can have a trunk, means it can configure like a straight one. Sometimes it's bent like this. Sometimes it's maybe bent like this. So it can bend. You can bend it. You can deform it. Okay. And you can give it in any shape. Now here in this example, you can see that there is certain object has been placed. A blue color object has been placed. Okay. And this object, sometimes it is placed in some location, sometimes it is placed in some other locations like. So the blue color object, okay, it needs to be tracked. Wherever the blue color object is moving, the robot should move to that particular locations. Now the question is how you will control it, how you will move it, how you will give instructions to the continuum robot to move to that particular locations. Now this is an applications, this is the field of applications of robotics, okay, with the AI. So what we are trying over here, we are trying to find out the locations of this blue color object through a camera. So basically these are the camera stands are there. So above it there is a camera unit. So the camera will grab the positions of the blue color object. It will find out where the blue color object is located. And then it will give an instructions to this white colored elephant trunk or the continuum robot to move to that particular locations. Not using any kinematics, conventional type of kinematics. Okay. So with the help of these AI systems we develop that to reach that particular locations, what should be the configurations. And this particular robot is driven by a number of actuators units. So that the backside of the robots, okay, so there are actuators, there are motors are placed. And this is basically, it is driven by the strings. It is driven by the strings. So there are strings are there. So if you pull the string on the push the string, then this configuration will change. So this is an applications, AI applications of in the field of robotics field, AI applications. I am showing another applications of this IoT, and it's not playing properly. It's so slow. I don't know. It's not coming like a video, it's coming like a static images only. So you can see that this is balloon. Okay, this is a blimp. We call it as a blimp. Technical name is blimp. It is filled up with the helium gas, and it can fly in the sky like in the air. It can fly like. Now the objective of development of such type of system is that it can be used for the surveillance purposes. Okay, so what you can do, you can place this kind of objects. Not coming. I don't know why it is not coming. This, huh? हाँ ये it's playing in the laptop properly.
नेट का दिक्कत है
नेट का
सर डाउन कर रहे हैं दिक्कत ना सर को गूगल मीट प्रेजेंट कर रहे हैं वो वहाँ दिख रहा है दिक्कत है प्रेजेंट कर रहे हैं entire screen
no that is okay but it's not showing it, not coming in the dynamic form like रुक जाते ना
सर दैट इज गलत है
So this is a blimp, okay, and it will fly in the air, and this blimp you can employ at the boundary of the India border like, okay. So there are certain incidents are there like somebody is trying to enter into the inside the Indian territory, okay, and then the question arises that how you can detect some such people, such persons, okay, because the boundary is so long, okay, so it is not possible for the human beings to track the boundaries, India border. So what we can do that you can employ this kind of aeroblames at different strategic locations along the boundary of the India border, and they will have a camera systems. They will have a camera, okay. So through the camera it will grab whatever it is finding at the bottom level, and then whatever the image is captured, that image is instantaneously it is sent to the control station, and the control station these images, okay, these are processed, and from there it is possible to detect that whether any person is trying to enter into the Indian territory or not. If the systems detect that somebody is trying to enter, immediately an alarm will be sent to the Air Force people at the boundary, so that they can take the necessary actions. And this is all possible with the help of these IoT systems. Which one? This you can do it manually. You can control it manually from the ground stations with the help of the your remote operators operating. Okay, remote operator. You can control it. Otherwise, you can control it also within a very small zone. You can control it in the remote form also. Both are possible. A drone is something different, like means these systems is something different, okay, and the drone is something different. This is more stable. This is more in the stable form, like, okay. So sometimes when the air condition means the turbulent condition is there, these systems behaves more in stable form, like. So whatever the images that you will get it from this kind of systems, that will becomes more and more or less it will be have a stable one. Anyway, we will see, no problem, we will see. So that way it is possible, means this is one of the applications area also, that you can apply a drone systems. In a drone systems or this kind of aeroplane systems, we can apply these IoT. There are propeller units there. There are propeller units there. Yeah, propellers. See, this is a joystick. Okay. This is a joystick, and this joystick is almost similar type, which is used basically for the gaming purposes, video games. Okay, so the children, they play the video games with the help of these joysticks. So this looks like similar to the joysticks, and with the help of this joystick, what you can do, you can control a robotic systems. A lot of problems is there. I am not able to show you. Stop. Can you see that there are two black colored robots are there, okay, and these black colored robots, they are like a right hand, one is like a right hand, another is like a left hand. Now there are certain tasks okay, which requires to be performed by both hands. Most of the cases we can do operations, means any kind of operations we can do with a single hand type, okay, but there are certain operations has to be performed that needs to be performed by the applications of both the hands. Okay, say for the nut and bolt tightening, we require the both hands operations. So this is an applications area where there are two robots, and these two robots are working in a collaborative way. They are working it, and they are performing certain tasks. Okay, and the instruction is provided by the human. Instruction is provided by the human with the help of these joysticks. Okay. And you can see so whenever this joystick is operated, these two robots will have a movement. Now you can just think of that this joystick is placed with the doctors. Maybe the student is replaced by the doctors. Okay. And that two robots, you can think of that these two robots are placed in a operations room, operation theater. So they are placed near to the patients. So the doctor is sitting in somewhere else. Maybe the doctor is sitting in Bombay. He is a very specialized doctor in a particular area, particular type of operations. And you are taking the help of these doctors for certain operations. And this is possible with the help of these internets, IoT. Because both the systems, the two robots, black color robots, and these joysticks, okay, so they should be connected through the net, internet. And here you can see these particular joysticks, that particular two robots, the human beings, the other accessory devices, medical gadgets, they are all connected with the internet. All are connected with the internet. And then only you can take the real benefit of IoT. So this is an applications area, okay, medical field, applications in the medical field, how the IoT concept is used. This is a small tabletop robot. Okay, this is not a purchased item. The students has made it as an experimental setup. Okay, and this particular manipulator of the robot, there has a at the end, okay, and end part of the arm, there is a gripper, and this gripper is basically a magnetic grippers. So the students, they developed an electromagnet, means they created an electromagnet and they have placed it at the end of this wrist part of the robot. Okay, and you can see that there are objects are there, and these are the ferromagnetic materials objects are placed. So these objects are placed at the different locations. The student is picking up the objects from one location and put it in some other locations, and then the robot is coming to that particular locations to for pick up the objects. Now here also there is no conventional type of kinematics is used. No equation is solved. Basically the robot is driven by the AI. So again there is a camera placed at the top of this platform, okay, where the objects are placed, the ferromagnetic materials are placed. The top of it there is a camera is placed. So the camera grabs the image and then it finds out what is the locations of the objects, XY locations, okay, and the robot is moving towards that particular locations. So the robot, previously the robot was taught that to reach to that particular locations, what will be the configurations of the different arms? What is the configuration of the first arm? What is the configuration of the second arm? Configuration means what is the rotation of this joint? What is the rotation of this joint to reach to the particular locations? And this is stored in a table, in a tabular form. So whenever the camera finds some object and it detects the locations of the object, then this information is sent to the robot controllers that okay, the object is placed in such and such locations. And the system is matching, and then the robot controller is matching its position, whatever the position is, has been provided by the vision systems. It is matching that whether this particular location is available in the Excel sheet or not. If it is available in the Excel sheet, it is going to that locations. Or if it is not available, then it is finding out, extrapolating that it has some known locations, known positions it has, okay, and known configurations is known. So if any unknown position is there, to reach to the unknown position, it is exploring from the data which is also already available from the known positions, and then it is reaching to that particular locations. Okay. So these are very simple examples of AI in robotics area, and which students you can take up any problems. Okay, undergraduate level you can take up with problem. You can develop this small type of robots. Hardly it will. Everything is available in the lab, like mechanical parts, mechanical components, small electrical motors. Okay, so they are all available. So you just design your arm. Okay, and only thing is that you require a camera systems also. So in the you can use some sort of laptop camera also. You can use it for grabbing purposes, image processing purposes also you can use it. So within a very cheap form, within a very reasonable price, maybe within 500-600 rupees, you can develop your own robot model. This is a hand. We call it as a robotic hand. Okay, and this robotic hand, it looks like a human hand. Okay, already I mentioned that in a radioactive environment, robots are employed. Okay, but in most of the cases, what happens? The object that needs to be handled, they are of regular in shape. Either maybe a cylindrical type of shape object, or maybe a spherical shape objects, or maybe a cube type of objects. Shape is regular. But say for examples that you have to handle an object which is of irregular in shape, maybe this kind of objects, very irregular in shape. Okay. Now the question is how the robot will do, how the robot will grab it. Now if you compare yourself with the robot, okay, how you grab it. If it is a cylindrical object, we know how to grab. If it is a cube, it's fine, we also know. If it is a sphere, we also know. But whenever it is an arbitrary in shape objects, then also we have to think that how we will adjust our fingers so that we can grip that particular shape objects. And most of the cases in your radioactive environment, okay, the object handling is a very critical work, critical task, and objects are not of regular in shape. Like. So we try to develop a hand, and this is known as the dexterous hands, and it looks like a human hand, because we find that this is a God created, God gifted hands, okay, and there is no, in the universe there is no other gripping device which is better than our human hands, okay. So we try to mimic, biologically we try to mimic the operations of the human hands and try to develop a electromechanical hand type of systems. And you can see that this hand is operated remotely. You can see that the some person is wearing a gloves, okay, and this is known as an electronics data gloves. This is a kind of data gloves, electronics data gloves. So the person is operating with the electronics data gloves, and this means whatever the joint motion is taking place, that is captured by the electronics gloves. And this information is sent to the internet, and that mechanical system is connected through the net also. Okay. So though in their systems it shows that they are very near to each others, so directly you can couple it, or in an indirectly, if you test your IoT concept, you attach your that gloves systems, the data through the net, and then from the net, okay, you process this data, process these informations, and then you give it the instructions to the robot hand, how the robot hand will move or operate it. Okay. So whenever the data is captured, by these data gloves, the data are very raw, and from the raw data one has to process this raw data, and then from there you have to find out that what should be the what I say the grasping, okay, what should be the grasp configurations, whether the object will be gripped like this, or whether the object will be gripped like this, or whether the object will be gripped like this. It will be decided based upon the data which has been captured through the data gloves. So not only you can see that utility of this IoT is not only that you just capture the data and then you use the raw data. There are a lot of processing operation is taking place. After capturing the data, a lot of processing operation, and the processing is really it is an important one. And here you can use this AI and the ML concept in the data. Apply your AI and the AI concept, ML concept on the data captured, and then you will find the real beauty of the systems of IoT. Okay. Only one or two I will just show. I'm just trying to provide you some idea about this is known as an exoskeleton systems which has been developed in our laboratory also, and these systems are basically for we call it as exoskeleton, okay, and these are useful for the person those who cannot walk, who has some sort of spinal cord injury problems, and then because of that they are always wheelchair ridden, they cannot stand, they cannot walk. So for them this is a kind of electromechanical kind of systems, okay, and this is definitely it is not IoT connected like, but wearing this device a person can walk like, okay. So a person can walk, you can see that the person is walking on a treadmill, okay. So similarly the person can, at least he or she can walk on a conventional floor. So that is possible. Anyway, so there is a controller unit at the back side. The controller unit is placed. Mechanical structure you can see. All the joints are connected with the, because you have to create the leg motions, no? The way we work. So similarly, the mechanical system also should work. And so this is one of the area we work, and this is known as the biomechanics area, biomechatronics area we work. Or sometimes it is also called as a biorobotics area. as I am unable to show you the videos or all that, this is not playing. Okay. And the last one I will, okay, anyway, I came out of the, most probably. Anyway, so I tried to show you that some of the areas in which we are working, okay, little bit in the area of IoT also, as I have already shown some systems has been developed, okay. One is the that gripping systems, hand systems, IoT based systems. The other one is of medical diagnosis purposes, okay, for medical treatment purposes also, how the IoT concept is used. And the others also I have shown you, tried to give you some idea on which area you can think of. So the area is vast. IoT and the robotics area, automation area is really, it is a vast area. Okay, but detecting of a particular problems and important problems, okay, is very, very important. Maybe on undergraduate level it may not be that much of importance, but at the postgraduate level and even for the PhD level, okay, those who wants to work in this particular area of robotics area, automation area, IoT area. So you have to find out a real problems. Okay, sometimes we just concept some fictitious type of problems and try to solve it. Okay, don't do it. So try to. There are so many problems are there. Okay, and even if you think of in a right directions, you will find the problems also, and try to give it the realistic solutions to all these problems. There is no dearth of problems in the human life, okay, but identify a particular problem in which area you will be able to contribute, you will be able to work, okay, and select that particular area and try to contribute in it. Okay, so if you have any questions, you can ask. We work in the area of hardware and the software development. Most of the things that I have shown you, this is a student's development. Okay, so I acknowledge the help and support that we receive from each and every students, undergraduate students, the master's students, and the PhD students also. This is basically of their work only. Okay, and we like to work in the hardware side. We are not that much of expertise in the software area. Okay, so our major strength is in the hardware development, both in the mechanical side as well as the electronic sides. And whatever the example I have shown, in every examples you will find that there are equal amount of mechanical items and there are equal amount of electronics items. So if you are from the electronic sides, there is enough scope for you to contribute in this field. If you are from the mechanical side, you have enough scope to add, okay, into it. Even if you are computer science, computer field, because all these programs are, means all these devices are autonomous. And whenever the systems is working in the autonomous form, that means some programming is involved. Without programming, the systems cannot work in an autonomous form. Like. So definitely, if you are from the computer science background, if you are from the IT backgrounds, definitely also you have certain tasks, okay, certain problems are there where you can also contribute. So we work in the interdisciplinary field, and the way we are moving means the industry is moving. Industry is always, it is asking that whether you have a good knowledge of, you have a specialized, you have a particular knowledge in a particular field, but do you have knowledge in some other field? Always they ask. Because industry is now applying this kind of machines, IoT driven machines, electromechanical systems driven machines. So if you have only the mechanical background, probably you will not be able to detect any problem in the electronics components. So company wants that at least you understand the language of electronics. Though you are a mechanical engineer, you understand the language of electronics. Though you are an electronics engineer, you should be able to understand the language of computers. So prepare yourself, it is better to prepare yourself for the different branch of it. You do not require a very depth knowledge of you require a depth knowledge only in your particular field in which you are graduating or you are doing the post-graduating. But at the same time, you should have a sidewise, you should have a good knowledge. At least you will be able to detect the industry's problems. Being an electronics engineer, if somebody, some mechanical engineer talk with you, at least you will be able to understand what he is trying to say. Okay. So, try to concentrate most in our case, in our time, in the 90s. Okay. So, at that time this multidisciplinary concept or interdisciplinary concept was not there. We studied only the mechanical engineering towards to the depth. But ultimately we found that the demand is, the industrial demand is something different like. And now if you visit any industry, you will find that most of the cases the industry is running in the automated form, automations. And automations only you can apply only if you have a knowledge of electronics. Any problem regarding automations you can detect only if you have a good knowledge of electronics. Not only the electronics, you require a knowledge of electrical systems also. Control systems also you should have a good knowledge. Also the software engineering. Sometimes you will find that the machine is everything is okay, only the software is corrupted or some problem is in the software itself. So you must be in a position to identify the problems. If you can give a solution, that's good, but at least you must be in a position to identify the problems. So any queries, any questions? Okay. So we can end up today. Okay. So I invite all of you, if you are from the Calcutta side, so you can visit our laboratory also. Okay. So if you find some time, you can visit our laboratory, and at that time we can show something more also.
Thank you, sir, for your insightful speech. As a token of our appreciation, I now invite our coordinator of Karyashala, Dr. Jayendra Kumar, sir, to give him a memento as a token of our respect. Please give a round of applause and honor our esteemed guest. I now announce the break for the tea. So we'll have a break for 10 minutes.
You guys नहीं थे.